Okay, now that we've learned how to solve equations, let's put it to use to actually solve some things from the real world. And again, the author's got some kind of fun examples. Let's choose one of these. The author mentions that in 2016, in the Olympics, that the U.S. Won 53 more medals than China. And not only that, but the total, I'm sorry, not 53, but 51. Okay, don't want to take more credit than we have due. 51 more. And the total medals won by both countries is 191. Okay, so the question is, how many did each win? Okay, so how do we go about solving something like this? When I teach this sort of thing in my class, I start by saying, if you know anything about the sacred scriptures of the Christian or Jewish, or for that matter, the Islamic religions, they all go back to Genesis. Genesis says things like, and God said, let there be light, and there was a sun. Let there be animals, and let there be plants, and let there be water, and so on. And the word let was the way all these things kind of popped into being. Okay, kind of cool, kind of a cool image. Well, we don't have that power, but we do have the power to say, over mathematics, to say let x be equal to something. So that's the power you have over mathematics. And so let x be, and we have a choice here. We could let x be the number of medals that China wins or the number of medals that the US wins. And one of those is easier than the other. I'm going to choose x to be the number won by China, number of medals won by China. The reason is because then I know that x plus 51 is the number won by the US. See that? So by using that as the standard, I have this for the US, and that'll make it a little easier. I could let x be the number won by the US, and then this would have been x minus 51. I'd rather add than subtract. So here's the ones won by China, here's the ones won by US, and I know that the total of both of those is 191. So I know that x plus 51 is equal to 191. And now it just becomes a nice algebra problem. I get 2x plus 51 is equal to 191. Subtract 51 from both sides, and you get 2x is equal to 140. And so x is equal to 70 when you divide by 2. So 70 is the number that China wins. If you add 51 to that, you get 121 is the number that the US wins. You add them together, you get 191. So this is China, and this is the US. See how that works? So kind of clever. Let's try another one. Okay, again, this is another one from the book. You've got 3 pieces of wood that are all being cut out of a single piece of wood, which is 70 inches. 70-inch plank. And you want a short piece, a medium piece, which is 10 inches longer than the short piece, and then the long piece, which is twice as long as the medium piece. Okay, and all 3 of those together add up to 70. Okay, now just to show you that things can be done different ways, the author lets x be the length of the medium piece. And that's a good choice, because then the short piece would be x minus 10, and the long piece would be twice as long as the medium, so 2x is the long piece. Okay, length of the long piece. So you add all those things up, and you're going to get x plus x minus 10 plus 2x. They all add up to 170. Oops, just to 70. Okay, so what do I have here? X plus x minus 10 plus 2x is equal to 70. X plus 2x is 4x minus 10 is equal to 70. Add 10 to both sides, you get 4x is equal to 80. X is equal to 20. So there's your medium piece. And then your short piece, so this is medium. Your short would be 10 less than that, would be short. And the long one is twice this, which would be 40. And sure enough, 40, 50, 60, 70, they add up to 70. So that worked fine. Okay? Just to show you that it could be done different ways, let's let x be the length of the short piece. Okay? You've got your choice. In that case, the medium piece is going to be x plus 10, right? That's the length of the medium piece, 10 inches longer. And then the long piece is twice as long as the medium. So there's twice as long as the medium. And so now we'd add those up. And let's see what we get. So we get x plus 10 plus 2 times x plus 10. And again, that has to add up to 70. So we get x plus 10 plus 2x plus 20 is equal to 70. I have x, and 2x, so I have 4x's plus 30 is equal to 70. Subtract 30 from both sides, you get 4x is equal to 40. Divide both sides by 4, and you get x is equal to 10. So there's your short piece, which we had before. The medium then would be 10 more than that, which would be 20. And the long one is twice that, which would be 40. So either way works. There's nothing magic about making a choice. Sometimes one ends up being a little bit easier than another. So as you get good at these, you start kind of being able to think ahead and see which one might be algebraically easier. But they all should work. Okay? Here's another one, again from the book. Some person has $40,000 to invest, and they're told by their financial accountant that they have 2 options for investing it. They can put it in some sort of probably bonds for 2% interest, or they could put it in maybe some sort of stock combination for 3% interest. So you've got 2 options. And so you want to put some in here, and you want to put some in here, and you want the total income from all of your interest or growth of these things to be, for whatever reason, $10,020 a year. Okay, I have no idea why they chose that, but suppose so. So that's your goal. You want to put some in here and some in here. And you want your income, maybe because that's what you want to pay rent or something else. You want it to be $1,020 a year. So let's let x be the amount in bonds. Okay, we'll say that this one is bonds and this one is stocks. Okay. So if x is the amount in bonds, and you've got 40,000 total, then this is where you have to do some thinking. 40,000 minus x would then be the amount in stock. Agreed? So once you make your choice, you got to live with it. And now what do we know? Now we know that 2%, that's 0.02, times the amount you have in bonds, plus 3%, that's 0.03, 0.03, I'm putting the 0 there just so you don't lose the decimal place, times 40,000 minus x is equal to 1,020. Okay? Now, I just don't like decimals. I don't like fractions. I could write this as 2 over 100 and this 300 or whatever. I'm going to multiply both sides by 100 just so that I don't have to worry about these decimals. If I do that, if I multiply this by 100, I'm going to get 2x. If I multiply this by 100, I'm going to get 3 times the quantity 40,000 minus x. And now if I multiply this by 100, it's going to be this with 2 more zeros behind it. Okay? You wouldn't have to do that. That's one of my algebraic tricks that keeps me from having to deal with the decimals. So now what? What do? We can multiply this out. You're going to get 2x plus, that's going to be $120,000 minus 3x is equal to $102,000. Okay? Let's do a couple in our head. Can you do this? This 2x minus 3x is a negative x. Agreed? 2x minus 3x is a negative x. So since I have a negative x on this side and nothing over here, I'm going to just add x to both sides. So that negative x I'm going to bring over here. It's going to become a positive x. So that takes care of that. Then 120 minus 102 is going to be 18,000. So there it is. If you put 18,000 in bonds and 22,000, which is 40 minus 18, so this is bonds and this is stock, that should end up giving you your $1,020. Now let you finish this on your own. Go ahead and take this times 0.02 and take this times 0.03, and I'm confident of my own work here. You should get 1,020. Okay, that's the idea. Okay, so that's a little more practical, something you might want to do sometime. You can never be guaranteed that anything, bonds are fairly, not guaranteed, but they're fairly assured. Stocks not nearly so much, of course. Okay, the author does one nice problem with distance and rate and so on. Instead of doing that one, I'm going to give you my own, which comes from my own fun and adventure. I love to kayak. And if I'm in a fast kayak, if I'm really pushing myself, I think I can go about 5 miles an hour. Okay, that's a hefty speed. Maybe that's a bit optimistic. But suppose I'm going 5 miles an hour. I'm on a trip where I'm doing that. That's through the water. That's through still water. And now I get in a river, and I'm going down the river, and say the current is pulling me along as well. So the current is adding to my speed. And this is my speed through the water. And then the current is pulling me along as well. And I end up going all the way down to a certain spot, maybe in 3/4 of an hour. Okay? So 3/4 of an hour it takes me to go downstream. And then I turn around and I head back upstream. So it takes 3/4 of an hour to go downstream. And I realize that I really had too much fun going downstream. It takes me 3 hours to get back, to return. And the question is, how fast was the current? Okay, how fast was the current? Okay, so kind of a nice problem. Okay, and the key to this is to remember that distance is equal to your rate times your time. Okay, your distance is equal to the rate times the time. So when I was going downstream with the current, my rate, we have a big let to do here. Let's let x be the speed of the current. Okay, there's our big let. So going downstream, I'm going at 5 miles an hour and the current is going whatever it is, and so my speed along the bank is going to be 5 plus x. Agreed? That's how fast I'm going downstream. And I go for 3/4 of an hour. That's my time. And so by the time I multiply this by this, that's how far I've gone downstream. Now, I don't even have to know what this is. All I have to know is that I have to return the same distance going upstream. So whatever this distance is, these two are the same. So going back upstream, now what's my rate going to be? I'm going at 5 miles an hour through the water, but now I'm going against the current. So the current is holding me back. So it's going to be 5 minus x, right? If the current were 1 mile an hour, I'd be going 6 miles an hour downstream, and I'd be going 4 miles an hour upstream. So going upstream is going to be this, and it takes me 3 hours. Okay? So it's kind of interesting because it shows we don't even have to find out what the distance is. All we have to do is realize that since those two times are the same, since these two distances are the same, this distance, which is going to be 3/4 times 5 plus x, has got to be equal to 3 times 5 minus x. And now we can actually find what the speed of the current is. Let's go ahead and do it. Again, I don't like fractions, so I'm going to multiply everything by 4, and that's going to give me 3 times the quantity 5 plus x is equal to 3 times 4 is 12 times the quantity 5 minus x. Okay? And now if I multiply this through, I'm going to get 15 plus 3x is equal to 12 times 5 is 60 minus 12x. So now I can add 12x to both sides. If I add 12x to both sides, I'm going to get 15x over here. And if I subtract 15 from both sides, I'm going to get 45 over here. So if I divide both sides by 15, I get x is equal to 3. So the current is going at 3 miles an hour. And now that I know that, I can actually determine how long of a trip I took. I went what? 5 minus 3 is 2, so I went 2 miles an hour coming back upstream. And I did 2 miles an hour for 3 hours, so this was 6 miles. 6 miles. Okay, if I took my 5 plus 3, that's 8. 8 times 3/4 is 6 miles this way as well. So I went 12 miles total, 6 going up, 6 going down. So kind of a nice problem. These are all fun. They're all fun problems to do. The power of them is just to say let. Take command of mathematics and go from there. Okay, very good.